Hello, our presentation for today is Intellectual Property Protection for Video Games, based on the paper co-authored by Dr. Robin Sloan and myself. I am an assistant professor in intellectual property law at Durham Law School. I specialize in IP law and legal issues relating to technology. I also practice as arbitrator in IP and commercial law.
Hi, my name is Robin Sloan and I'm a senior lecturer in computer arts at Abertay University in Dundee in Scotland. My research interests broadly cover game design and production practices, and I tend to focus on the practical and applied aspects of game creation, considering how games are developed and produced in industry by games professionals.
Our co-authored paper examines intellectual property protection for both UK and Chinese games companies with digital content as their key intangible assets. Here, IP refers to copyright, patent, design, and trade secrets. The research questions here are first, whether the current IP law has afforded adequate protection for games. Second, how the IP legal regime can be reformed to effectively protect the industry while maintaining a delicate balance between IP owners and other stakeholders like the platform and the end user. Our presentation is divided into 5 sections. Robin will go through the first 3 sections with a focus on copyrights, and I will talk about patent and design rights protection for games. And last, we will propose a reform to the copyright system and recommend an optimal model for IP protection.
So, in any discussion about protection of video game IP, it's important that we consider what the individual elements of a game design are, with the aim of then identifying what within the game is representative of the original idea or innovation. We can start by discussing how games are categorized. A standard model applied within the games industry is to categorize according to genre. Much of the game design literature addresses genre as a series of conventions that have become accepted by designers and players alike, where the overarching set of conventions determine the genre, e.g. sports, strategy or puzzle, while the conventions can correspond with common actions or game mechanics, such as running, shooting, or dice rolls. This approach to categorization helps to standardize how games are made, with which elements towards commonly understood types of game. We might then assume that genre is not where originality or innovation takes place. However, game genres do not remain static. Game design is a practice that embeds and expects continuous evolution of ideas, which can mean genres rapidly expand to include new elements produced by games professionals. Take the racing genre, for instance. As an overarching genre, we can define the common elements that make up this genre, but over time, evolutions can lead to original approaches to how the genre is realized. For example, a game creator may modify the genre by introducing novel elements of cinematics and storytelling, defining a new genre, or integration of a unique approach to strategic racing. Even relatively innocuous modifications such as adding other players and defining their roles can lead to novelty, but also new genres of play. And game design also embraces technological innovation into the process of generating new original ideas. Sticking with the racing genre, we can consider how racing games can be heavily altered through use of novel input or display devices, such as custom controllers that utilize accelerometers or motion tracking, or immersive displays such as AR or VR. The opportunities providing high level of user control, customization, and creation have accelerated in the past decade, leading to genres where players can create their own vehicles, tracks, levels, and share these through digital distribution networks. Not only does this add original ideas from developers, but also introduces the challenge of who owns content. And of course, superfast broadband, cloud gaming, and 5G connectivity can radically change how a game is designed, played, and experienced, such that a racing game can no longer be simply categorized by its standard genre description, and new genres emerge. When it comes to categorization then, we can observe that convention and what may be constituted common applications used throughout the industry can quickly become more complex through evolution and innovation, to the point where original ideas or expression may emerge only to then become standardized. Which brings me to a secondary challenge of understanding which parts of a game are expressive and therefore potentially of interest with regards to IP protection. To address this, I want to present 3 different conceptual models that describe how games work or are made, with a view to teasing out the elements of games that can contain original ideas. At the highest level, Miura's 2008 core and shell model separates gameplay, the core, from the representation of ideas within the game, the shell. Here we can consider that the core is the functionality of the game. This is the code base, which determines the rules of the game from launch to close, inclusive of how interactivity is curated, how the game is tackled, and how the game tracks performance and provides feedback to the player, etc. Conversely, the shell encompasses the audio-visual material that provide context and meaning to the game, including the graphics, the sound and music, and the narrative. As applied to IP protection, this model can be regarded as drawing a line between that which is functional and that which is expressive, with the representational imagery and audio that make up the game shell arguably aligning with the latter. However, this level of abstraction does not necessarily map well to a game maker's perspective on expression, if the assumption is that the original expression within games is constrained only to how it's represented as an audio-visual form. There are other top-down models that can be helpful to framing game maker understanding of expression in games. The MDA framework proposed by Hunaka et al. In 2004 stresses a distinction between mechanics, the game rules, dynamics, the operation and behavior of those mechanics at runtime, and aesthetics, the interpretation of the end user. Looking at MDA with the question of resolving what is purely functional and what is expressive, at first glance we might reckon that this is all about functionality. MDA in effect describes the way the code is developed and utilized by a designer who works from base mechanics through to desired aesthetic experience for a user, who experiences the game at an aesthetic level through which they can perceive system dynamics and underlying game mechanics. This model does not really account for representation as such. The focus is on the design and curation of play. To that end, is it strictly a functional model? This would be challenging if true, as we can reasonably judge that a curated play experience contains original ideas that ought to be subject to protection. A designer achieves aesthetic experiences for players such as a sense of empowerment, of challenge, or of community through creative development and alignment of game mechanics and systems, which are in effect rules produced in code. Although a top-down and abstract approach to understanding what a digital game is, both the core and shell model and the MDA framework problematize any notion that games can be neatly separated into distinct expressive and functional elements, when the game design realized through code is dismissed as purely functional. Another model adapted here from Fullerton combines the duality of rules and representation with the detail of crosstalk between these areas of game development, where formal elements encompass the fundamental objectives, procedures, and rules of a game, dramatic elements, the idea of the curated play experience or aesthetic, with the representational elements such as character, story, and world building, and dynamic elements consider the complex systems that manage the interplay of player actions, for example, within game economies, markets, and decision making in general. When we consider expression in games, then, where is the original idea, the creative expression of the game designer? What are the elements we are dealing with in practice? I'd like to close this evaluation of how games can be defined with a focus on how game developers understand the individual elements that are actually created and implemented within games. Fundamentally, we can dissect a game according to three types of content: audio assets, visual assets, and code assets. Everything that is built and implemented within a digital game falls into one of these asset categories, which at a base level we can consider entirely functional and without expressive qualities. Audio assets serve to play back sound and music, visual assets serve to render graphics on the display, and code assets serve to provide runtime functions and interactivity. Underpinned by design, we broadly group these into primary disciplines of programming, which involves the development of code, implementation of rules, definition of data structures and systems, and content production, which can include narrative, art and animation, and audio. Within these elements alone, then, it is difficult to determine a source of original creativity. These are simply the types of content that go into a game. However, past attempts to understand what game elements can be protected have often tried to break down a game separately into its audio, visual, and code elements, as there is some alignment here with other complex media such as films, within which there may be a desire to protect, for instance, its soundtrack. In short, it's not the type of game element that determines its route to protection, but the idea that the element exhibits. From a game designer's perspective, the audio content is not any more or less a product of originality than code content. Any discussion of IP protection must therefore consider how the original ideas within a game design are protected, irrespective of the form they come in, whilst also accepting, as discussed, that game design relies upon continuous innovation and evolution, which would be stifled if every new contribution was protected from subsequent imitation or iteration by other developers.
Now it's my turn to look at patents and designs. So what is a patent? A patent protects technical products or processes. Patents are granted for new inventions compared to the technology that has gone before, which is known as prior art. There are various categories of subject matters that cannot be protected as patents in the UK, including computer programs, presentations of information, mathematical methods, algorithms, and rules and methods for performing mental arts, playing games, or doing business. There are examples where certain methods or programs have been granted patents. For example, in the WB case, Warner Brothers has obtained a patent for the Nemesis AI system found in a game called Middle-earth. It protected a hierarchy of NPCs that interact and remember the player's actions. It also allowed players to use these NPCs to defend their own strongholds and attack those of other players. In the EA case, a patent has been granted to a graphic interface for interactive dialogue, as shown on the right. In the Bloomberg case, a patent has been granted to the method of simultaneous playing in a single-player video game. So different from patents, the appearance of a product or parts of a product may be protected by an industrial design. As a rule, the industrial design protects the external, observable form of a product. This might include, for example, the particular appearance, shape, contours, ornamentation, structure, or specific external features of the material. Therefore, the design of console and other hardware could be protected as the industrial design. Just now, we will look at different routes for IP protection for games. We can see that the route of protection depends on the subject matter and the category of the content. Copyright protection may extend to the appearance of characters, words, the architecture of towns and other locations, music, software, and objects, which could be weapons, costumes, and obstacles. While patent protection may extend to specific algorithms that are capable of being implemented in the game. Design protection may extend to external features of materials. Now we can also see that the threshold for protection is different. Copyright requires originality, while patents and design require novelty. Now the application process is different. So for example, in the UK, a single patent application which costs around £4,000 and takes up to 5 years to process. And last, the period of protection is different. A patent lasts 20 years. A design may last between 50 and 25 years, and copyright could last up to 75 years. So the optimal model for IP protection we would recommend is to view IP as a complex adaptive system, and in practice, make copyright, patent, and design work in parallel for them. So our conclusions. First, the current IP legal system is facing challenges. Gameplay and the dynamic layer involving a higher degree of interaction is stuck between the interface of copyright and patent, so it may not be protected either by copyright or patent. Moreover, implicit copying of grammatical elements without direct copying codes could be regarded as non-infringing. However, the practice of reskinning would cause damages to the original game. Therefore, we would advocate reform for copyright law. Games are becoming more user experience based. Consequently, a subtractive approach assessing copyrightability of an element separately from other elements of a game could not provide sufficient protection for gameplay and the content and the dynamic layer. Instead, a total concept and feel approach that evaluates copyrightability of certain elements from a user's perspective will work better. And last, we have recommended a model that can optimize IP protection for games. That's all for the presentation. Thank you.